Hey everyone, welcome back to All About AI Tech. If you're new here, smash that subscribe button and join our community of AI enthusiasts. Today, we're diving into the fascinating world of graph neural networks, or GNNs, and how they power recommendation engines. Ready? Let's get into it. Ever wondered how Netflix always seems to know what you want to watch next? Or how Facebook suggests people you might know? It's all thanks to something called graph neural networks. First off, let's break down what we mean when we talk about graphs in this context. I don't mean bar charts or line graphs, but graph data structures. Imagine this like a social network. Think of your Facebook profile. You're connected to friends and family, right? In a graph, each person is a node, and the connections between them are edges. Each node could be a person, and each connection represents a relationship, like friendship. For instance, you might be directly connected to your brother and your high school friend. This is a very basic form of a graph. Now, let's say your brother is connected to his boss. This introduces the concept of degrees of separation. In simple terms, you are closely linked to your brother, but you're one step away from linking directly to his boss. Things get more interesting when we add more data. Let's say we add a weight to these edges. For example, the number of times you message someone could be the edge weight. The more you message, the thicker the line. This gives us even more insights into how closely connected you are with each person. We can also make our graphs heterogeneous, which means using nodes of different types. Let's apply this to a recommendation system where we have nodes for people and nodes for items, like anime. Imagine this. You and your brother enjoyed watching Pokemon, but your brother also loved Attack on Titan. The system can recommend Attack on Titan to you based on this graph, even if you haven't watched it yet. When you scale this idea, it's easy to understand how platforms like Netflix and Facebook use massive graphs to make personalized recommendations for millions of users. Now, how do graph neural networks fit into all this? GNNs use these graph data structures to train models. They have layers just like traditional neural networks, but they focus on the relationships between nodes and edges. One key component in GNNs is the message passing process, where each node shares information with its neighboring nodes. This helps the network understand the context of each node and edge. In this project, we used GraphSage, a type of convolutional layer for graphs. Think of it like a convolutional neural network, CNN, for images, but instead of pixels influencing each other, it's the neighboring nodes passing messages. Each node sends a message to its neighbors, enabling the network to understand user preferences and item characteristics better. This is key for making accurate recommendations. Finally, a linear layer is used to predict outcomes, like how much you might enjoy a new anime. The linear layer processes the information and outputs predictions based on the features provided by the previous layers. To summarize, graph neural networks take graph structures, apply message passing through nodes and edges, and use layers to build an understanding that leads to predictions or recommendations. Simple, right? For this project, we used a dataset from Kaggle, featuring 6,000 unique users and their ratings for various anime. Due to limited resources, we sampled the data, but imagine the potential if more resources were available for training. Before we wrap up, let me know in the comments what you think about graph neural networks. Do you have any questions or ideas for future videos? We're continuously striving to improve our video quality and content for you. Help us build a thriving community where we can share and learn together. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss an update. Thanks for watching All About AI Tech. Catch you in the next video.